We're good? All right. And so my name is Matt Steele. I'm a consultant, and I work in our services organization with partners that have support services contracts with Microsoft. So I'm not a consultant from the say I work on a project, but I work more with our ISV partners to enable them to integrate with products like Exchange. Other peers on my team do support around Windows Phone, Windows Server, SQL, that kind of thing. My focus is on Outlook, Exchange, and really Exchange from a bunch of different of the protocols that we talked about today. So I work with ActiveSync partners, different partners who are doing Exchange Web Services, people doing different things with web services, so building a client versus building a service application versus trying to optimize traffic over the wire. So I kind of have a perspective looking over the list of folks that are here and kind of where your questions may come from in different areas that you're concerned about. I kind of have a perspective on that and have worked on a number of those areas. So if something I'm addressing here doesn't really fit into one of your scenarios, but you want to ask a related question about a scenario that you care about, feel free to jump in and raise your hand anytime, and we'll kind of dive into that. Kind of with that in mind too, and in the topic of protocols, this talk and the content here, and actually the content in the next section and session I'm doing tomorrow, is really around what we call best practices. So this is implementation details of how to implement these protocols correctly. And so it kind of goes beyond what's in the protocol, which is just about showing you what you can do or what's possible. And this is also from the perspective of general best practices. So it's not exactly how Outlook 2011 does anything or how Outlook does anything. This is just kind of general best practices that you would go about if you're writing your own app. We can talk about that, how Outlook 2011 might do something and related to web services, or how a client might do that, if that's relevant to any of you. So feel free to kind of, ask a question to make it more relevant to the scenarios you care about. This first session is about reading and writing data. And so very simply, we'll talk about reading, some best practices about reading data. We'll go over a few of the ROPs, or a few of the SOAP operations that you would use to do that, best practices around that, and do the same thing for writing, and then talk a little bit about backup and restore. So first topic, reading data. And so to kind of bring this back to the protocol documentation. So there's two basic operations that we use to kind of search within a mailbox. So this is accessing data in a mailbox when you don't know exactly necessarily what you're looking for. So a find folder operation is going to give you a list of folders underneath a given starting point. So there's a set of enumerations that would dictate a common folders like root, inbox, sent items, etc. You can pass in one of those, or an item ID or a folder ID, and get the subfolders underneath of that. You can also search, so you can pass what's called a restriction. We'll talk about that in a little bit. Same thing for find items. So you're looking for items within a folder by a set of search criteria, or just saying simply, give me all of the items in a paged view underneath this specific parent folder. There's some links here. So, as we talk about this again, the top half is the protocol. The bottom half is MSDN SDK references for the operations. There's lots of good information, examples. So I have links to the actual reference for these operations, and then some sample code that we have online as well. So to kind of just take a look at the anatomy of a find item request here, and just to point out a couple things. So this is the SOAP for a find item operation. The key basic parts here is, one, we have a traversal setting, which here is set to shallow. That doesn't imply that there's a deep traversal, which would allow you to search every subfolder underneath the given parent folder. The actual values here are to look in the actual folder contents, like you would see in Outlook, the items that you would see. There's also an associated contents table, which are the hidden items in a given folder. And then there's the dumpster. So those are the items that were soft deleted out of that folder. The next important piece here is the item shape. And so this is the where we declare the property set or the property bag for each item that you want to retrieve. So in this case, we set a base shape of ID only. The other option is all properties. So we're retrieving just the item ID, and then we're adding to that one additional property of subject. So if you had 100 items in your inbox, you sent this request to it, you would get back for each item just the item ID and the subject. If you did all properties in the base shape here, that would give you not all properties. If you're familiar with MAPI, it's not like a get props null where you get every property on an item. You're getting all of the EWS schema properties, which is a subset of every property that may be in the database on the item. So it's an important distinction. We'll dive into that a little bit more. The next section of note here is the index page view. And so this is, we're setting that a maximum of 6 entries would be returned. And we can set an offset. So this allows us to page through a large result set. So if we have 1,000 items in our inbox, we don't send a request like this and then get a response back that tries to stuff all 1,000 items back in a single request. We can page that out into multiple requests and control how many results are in our set. And then finally, the parent folder ID. So it's simply the parent folder or folders that we want to do this request within. So if you think about Outlook, a find item might be in the content view of a given folder. So the top pane, we'll talk about a get item, which would be more the detailed view when you open an item up in an inspector in Outlook. So some best practices here related to what we just talked about. The index page view is very important. So if you don't, as I described before, if you don't pass index page view with one of these requests, you're going to get a response of every item within a folder or every subfolder from the parent folder you sent. So you always want to make sure you use the index page view. We were talking about before the EWS Managed API. It does things to help you in this regard, and one of those is it forces you to set a paged view every time you do a find item request through the Managed API. If you're just using the SOAP, you're just following the protocol. You might not know that. It kind of makes sense if you think about it, but you don't have to do it. So sometimes people run into that. Find item, we'll talk about get item in a minute. Find item is relatively efficient. It's mostly because of this bottom set here. So find item is an optimized call. So it's just really trying to get you a result set that gives you the contents of a folder. The expectation is that you would do a get item to go and follow up on any particular item to get, say, the body or the attachments or the rich recipient information, that kind of thing. So you can see some limitations here around, this is mostly going to affect you with attachments and body, that you're not going to get the full contents from a find item. And we'll talk about get item in a minute. So get item, so here's the documentation on that from a protocol perspective. We also have a get folder operation. So these operations work off of a known item or known set of items or a known folder set of folders. So unlike a find item call, a get item, you actually pass it explicit item IDs. So you already know that those items are in a folder. You have the item ID, and you want to go and get detailed information about that item. Same thing with get folder. And here's the SDK reference. So if we look at that, first off, here's the item ID, so we can pass it a set of item IDs that we want to get. We have the same idea here of an item shape. And so basically all you're doing is sending a set of items, and instead of a page view here, you're managing just the number of item IDs that you put in this section. And then in your base shape, again, you defined a base shape, and then you add properties that you care about. So I wanted to point out just 2 more things here. In this base shape, there's another value called default. So I talked about ID only, and I talked about all properties. Default is another option. The default base shape for an option would be, the way to think about that is the default property set for a mail item versus the default property set for a contact or calendar item. So you're not doing an all properties request to get all EWS properties back. You're just saying, give me the default property set for that given item type, even if you don't know what it is. So if you have an item ID 1234, you could say, give me the default property set. If it happens to be a contact, you'll get the display name, phone number, and things like that. If it happens to be an appointment, you'll get the start time, end time, et cetera. That could be like in a client scenario where you have a folder that may have contacts in it, may have appointments in it, may have mail items in it. You don't know. You have a collection of item IDs, and you want to go ahead and get that data if it exists on those items. Another thing that we'll come back to is include MIME content. So you can actually retrieve the MIME content for any given message. And we'll talk a little bit about where you might want to do that and what that means in a moment. But that's how you do that. So it's not actually a property like when we were looking at before in the additional properties declaration. It's just a separate flag that you set to true. So getting into some of the best practices here. So the basic, kind of the first step, and one of the things you might see is, like I said, when you're doing these find item calls and you're not using a page view, or you're using a get item call and you're just passing it 100 item IDs and trying to get all the properties back on that. You want to find a balance between being chatty and being chunky. So making a lot of small calls versus a few really heavyweight calls. There's a lot of things to take into consideration, especially in like a situation where you're accessing Exchange Online. You're thinking about the latency between your client or your service and the Exchange server. So if you're in a low latent environment or in an environment where your connection may drop or something like that, you may optimize this a little bit. There's also optimizations that you'll notice in sending a batch of requests to the Exchange server. So when it hits the CAS, there's optimizations we do on the mailbox connection from the CAS server to the mailbox server on the back end, that if you send a batch, you might get a better response time for an overall batch back to you if you send more items than just, say, sending 5 or 10 at a time. Then there's kind of you take that too far and you send 10 or 100 or 200 items, depending on your property set requested, that might just create a response message that takes forever to get back to your client. So you really have to test with this, kind of find the balance that works for you. I've got a blog post that just kind of shows just a random scenario that I show you how to set that up, how I evaluated for that scenario what the best batch size was, and working through that. Goes back to what we can come back to at the end in a demo, but what Venkat was talking before about the IIS logs, looking at that on the server, and then also evaluating kind of your latency between you and the server, and then the latency caused by just the time to process the request on the server. So property sets, talked about this a little bit to go deeper into that. So I showed you include MIME content, and now I'm telling you not to do it. So the basic flag here, what it does is it tells Exchange to, for any given item, take all the properties that are stored in the Exchange database in the mailbox server for that item, and then basically create on the fly MIME representation of that item and then send it back to you in a stream. So that process, the properties are requested from the CAS to the mailbox server, and then the CAS server assembles all of those properties together, converts that to MIME, and then sends that over the wire. So it can be pretty CPU intensive, especially for large items. It's not typically stored in the mailbox, so there are situations where if an item came in through, say, like SMTP, and it came in as MIME, then we store like the skeleton of the MIME content, we store pieces and parts of it, and that makes it not an entirely, it's not entirely a recreation of that item. There's some pieces of the MIME that are there and kind of optimizes it, but it's still pretty CPU intensive compared to just, say, asking for the body, the attachments, and the recipient's table and things like that through the EWS schema properties. What you might find, so for for folks who are interested in how like Outlook 2011 or Entourage or the Mail Client and some other systems that use EWS, how they might work, you might find that some clients that are EWS based actually primarily work through MIME because they also support, say, like POP or IMAP. So their client store is MIME based, and you'll see them requesting MIME for every item, or you'll see them creating items via MIME, and they'll just pass the MIME stream up and set all the properties that way. So you may see some of that over the wire if you're looking at how different clients work. The optimal way, even for those client scenarios, is that what we would want is that they use EWS properties rather than the MIME content. So again, kind of talked about this too, or at least started to. You can use, I told you about all properties. I told you about default base shapes, and now I tell you not to do it. The best performance that you're going to get is by using the ID-only base shape and then requesting only the properties that you need. There's a lot of EWS schema properties, a couple in particular that I talk about in this blog post and the calendar, that are calculated. So there's things like, there's EWS schema properties in the calendar on an appointment item for adjacent appointments or modified occurrences, things like that that come down. So if you use the all properties or default base shape, those calculations and properties are sent back to you, and that adds to the total latency that you witness. So if you don't need those properties, you can really optimize your throughput by dropping them from the property set. Just a few more optimizations here. So an item ID in EWS is made up of a unique ID and a change key. The change key is what signifies the change number for a given item. If you pass that with the item ID when you're retrieving an item, you'll get a slight optimization. You'll save some RPCs on the back end on the CAS server. And so that's always a good thing to do if you have that. And we'll talk about update item in a minute where you're required to pass the change key with that. Schema properties versus extended properties. So if you're familiar with MAPI, there's this idea of property IDs, prop tags, namespaces, etc. All of that's available to you in EWS as well through what's called extended or additional properties. So you can do that. A lot of folks who are migrating from MAPI to EWS are trying to do just kind of like a one-to-one port of what they used to do with MAPI, and let me get all of these properties. Let me do the exact same thing with EWS. So I'm going to collect all my prop tags and try to set them or read them with EWS. It's better to look at the schema properties first. There's optimizations in the schema properties. There's data formatting and things that we do to make the properties more readable. There's things that we do to basically correlate various different extended properties into one schema property that gives you all the information you need and makes more sense. So you really want to start with the schema properties, and then where those don't get you the information you need, then go to the extended properties. So again, use them in rare cases. You can do some kind of nifty things in a find item call. So I talked a little bit about the limitations of a find item versus get item. You can use things like a find item call with an extended property to PR body, which is basically the prop tag for the body, which you can't get through the EWS schema in a find item. But if you pass the MAPI property, you can get that data back. So you can do things like that to kind of save you a little bit there. But typically, you're going to choose the schema properties of the extended properties. And again, there's no concept of give me all of the properties of an item. So there's no get props null in EWS. So a lot of people will use that base shape all properties and think of that as a way to basically retrieve all the properties of an item, save them to disk, and then try to write them all back to restore that item. And it's not the equivalent. It's only the subset of EWS schema properties that you get back. Okay, any questions about reading data, any of that? All right, so move on to writing. So here's the protocol links for where writing happens, and really what I'm going to cover here is create item and update item. There's also analogs for folder as well. So the create item operation obviously creates a new item, updates an item. You pass basic flags on both these operations can trigger a send. So if you call update item on an appointment or a meeting with multiple recipients on it, you can say, send an update. And so in one call, you can update that appointment and then send out the updates to all the attendees. Here's the MSDN references. These examples are for email. There's also examples right there in the SDK for appointment operations as well. So just taking a look at the create item here, and I'm kind of walking through some key points of that. First thing is the saved item folder ID. So this is where you're going to save the item. So in a situation where you're just creating, say, a contact or something, obviously you're going to save that in the contacts folder, an appointment in the calendar. In a situation where you're sending email, which is the case here, we're setting this to the send items folder. You could set that to any folder you wanted to. So you could send mail and have it saved anywhere in a mailbox. That could be what we call a distinguished folder ID, which is that enumeration by name for a known folder, or you could have a folder ID, which is just any folder that you created in the mailbox. Then you set, in the message here, you set the different properties that you want to set on the newly created item. So in this case, I'm setting the item class to IPM.note, setting the subject, the body. I could set the body type to be text or HTML. Here's the body. This is the actual message of the body. These are the recipients that I'm setting here. So, or actually, sorry, this is the sender. So I could set that to be another email address and send on behalf of if I wanted to. And this is the recipients collection would be here. So 2 recipients, and you could set that. There's also CC recipients and BCC recipients. So update, we'll talk a little bit more about conflict resolution here. Message disposition is save only. This is where in a scenario for like updating an appointment, you would set save and send to recipients, or save only if you just wanted to save a change to an appointment in your calendar and not send an update. Then we have the item changes element, and then you could have multiple item changes within one request. So you could update several items at a time. I'm sorry, I skipped over conflict resolution. We'll actually come back to that a little bit. That's set to auto resolve. So in each of these item change, I send the item ID and the change key. Talk a little bit about how that works in relation to conflict resolution. In the updates, these are the actual collection of updates. So I could set a field, I could change a field, add a field, delete a field. And this is the field URI. So this is the name of the field. This is from the item schema, the sensitivity property. And I'm setting the value of that here. So just a few best practices for basic write operations. So if you're doing, we'll talk more about sync in the next segment. But if you're doing a situation where you're synchronizing items, you don't want to write back to that item that you processed that. You don't want to write a different, a property back saying that you processed that item. You just synchronize, because then you'll get another synchronization event that item changed, and then you'll write back and you'll just get in a loop. You want to update only the properties that have actually changed. So you don't want to update properties just for the sake of updating. That's not anything more than just kind of common sense, just reducing the request size, reducing the work on the Exchange server. Interesting note about the isRead flag. So this is the, where you're marking an item as read or unread in a client. If that's the only thing that's changed, then separate that out. So and don't just set that flag to the same value it is, just as part of a bulk update of other properties. It's actually maintained at the folder level, not at the item level. So there's a different optimization for modifying, changing that property value. So you really want to kind of be cognizant of that. And not just set it, reset it to the same value it already is if you don't need to. Okay, so change keys and conflict resolution. So In a situation where you're synchronizing items and you're calling update item, if you synchronize an item down to your offline cache, right, and you make a change on your client, you have the item ID and the change key. You send that up with your update item and you change, say, the subject. In the response back to you from Exchange, you get the same item ID back and a new change key. So that's the latest change key that you get back. If you are also synchronizing on the back end, so you do this update of this item, and then you call sync folder items, and you get changes back, and you get a modified event for that given item, you can look at that change key, and if the change key you have that you got in the response from your update item is the same one that you're being told just changed, then you know you have the latest change, and you can throw that out. Also, when you're calling update item with the change key, if you had a situation where you sync the item down, and you have an item ID and a change key, and you send that up, and you try to update the subject, if your conflict resolution is set to auto-resolve or never overwrite, that means that if another client came in and changed that item underneath you, and your change key that you're sending up doesn't match the latest change key that Exchange has because the item has been updated, you'll get an error back. And you'll know that you need to go retrieve the latest version of the item and retry. So that'll help you with conflict resolution. It's important to note that the red flag, so that read state of an item, just like we talked about, it's stored at the folder level. So when you're doing this conflict resolution, the auto resolve and never overwrite and the change keys aren't related to that is red flag state. So just keep that in mind. That's not typically a critical piece of information that you're worried about, but you could stamp over other changes in that case. So moving on to backup and restore. Any questions about writing or the best practices there before we move on? So backup and restore is it's kind of an interesting topic. It comes up mostly when we're talking about you had a service it was maybe based on MAPI that did backup and restore of Exchange, and you're now looking to port that to EWS, and you're looking for parity between EWS and MAPI. There's not great parity here, so it's important to kind of understand what your options are, what you can do, what you can't do. So basically, if you're going to write a backup app with EWS, there's a couple different things that you would look at or take into consideration. One, you could back up MIME content. So you can, like we talked about, you can extract MIME. Not the greatest idea, but in a backup case, you're trying to get some representative stream of an item that you could store offline and then restore. So you can do that with MIME content. In Exchange 2010 SP1, we added export items and upload items, which we'll talk about in a little bit. With MAPI, you might have extracted an item to an MSG file format. There's no ability to do that with EWS. You also can't create a PST with EWS, so you can't pull every item out of a mailbox to a PST with EWS. Exchange PowerShell does have some support for PST export, at least on premises. So you have this idea of the new mailbox export request. So that's a request where you can basically point it at a mailbox, give it a file share, and Exchange will export all the items in that mailbox to a PST and drop it in the file share. That isn't available currently in Exchange Online. So the MIME content backup, like I said, the export items and upload items are new to Exchange 2010 SP1. MIME content has been there since the beginning, so you can support more versions of Exchange with a MIME content backup. It's not a full fidelity backup, so it's not every property, it's just the MIME property. So it's just those RFC standard properties and the X headers and things like that were on that item, but it's not every MAPI property that's on an item if you're doing like an MSG export with MAPI. So you can create items with MIME in a restore scenario. You can use get item with the MIME stream in an export scenario. And again, we talked about this point already, that results in a little bit of CPU intensive work. So export items and upload items, these are documented in this what's called the bulk transfer protocol, and so it documents these two operations, export items, upload items. It's also in the SDK reference. There's also an MSDN article on using these with Exchange Online. So there's a fair amount of documentation around it. It is supported by Exchange Online and Exchange 2010 SP1. It is somewhat useful in a purely backup and restore scenario, but what it's not useful for, based on this last bullet, is a situation where you want to extract a stream of the item. It's very quick, but you can't parse the stream that you get back. There's no documentation on how to parse that stream, so you can't use it to, say, pull the item down, pull off different properties, index them, and then have that be searchable and send it back up. What you could do is use like a get item with an export item call. Use the get item to pull the properties from the item that you want to index. Use the export item to get the stream that you store related to those index fields and store it that way. But this by itself, the stream you get back, should be considered an opaque stream. There is some kind of third-party projects and documentation that you might see on that, but that's not something that we have documented officially or support. So this is what that looks like. So this is export items, and it's very simple. You're just handing it the item IDs that you're exporting, and you get back basically just the stream of data. So it's base64 encoded stream for each item that you request. It's pretty straightforward. On the upload items, it's kind of the same thing. You have the option, you set this create action, so it can be actually a create new, or you can do a create new or update, or you can do just an update. So you're assuming that the item is already there and you would get an error back. It's not, this create would fail if that item already exists. And then there's a little note here about the restricted maximum import payload of 25 megabytes. So there are some restrictions about that. So this, again, is really only useful if you're doing it like just a core backup and restore scenario, not necessarily like an archive or discovery scenario.
So is that like a fast transfer in RPC?
Yeah, it's very similar to that. And actually, if you look at the stream, the data stream that you get back, you'd almost think you could parse it based on the protocol documentation from the MAPI documentation on the MAPI side, but you can't. So it's not exactly the same. All right. So as far as reading, writing, and backup data, that's what I've got from the presentation standpoint. I do have some demo stuff that we can walk through. Any questions before I do that? All right. So I'll just walk through a couple things here, just kind of real quick. And what I really kind of wanted to do was step back and talk a little bit about what Venkat and Daraji were talking about before. So they were talking about user agents and IIS logs, and so kind of understanding either the behavior of your app or some other app, an Outlook client or anything like that against Exchange. So basically what this is the, we mentioned IIS logs, and there was a slide where they showed the different pieces of data, kind of different diagnostic information that's in the IIS logs. This is actually in Exchange 2010 SP2, we've moved a lot of that diagnostic information into an Excel, a CSV that's actually outside of the IIS logs. And so what this is just that CSV file imported into Excel. And so you can do some kind of neat things with that. So what you're seeing here is all of the EWS requests made to a particular server over a period of time. And we log some really kind of useful information. So date and time of the request, authentication type, authenticated user, the user agent, which is really important. So I'll show you how that can be pretty useful in a moment. IP addresses, we even log, so this is the impersonated user. So this is, if that EWS request had that impersonation header, this would be the impersonated user. talk about cookies and Infinity. Tomorrow, this is the Exchange cookie that's being used for each of these requests. And then we show, these are the different budgets. So when we talk about throttling, this is information on the current state of different EWS throttling budgets that are maintained on that CAS server. So when we talk about that, we'll probably pull this back up when we talk about that tomorrow. Then the kind of interesting thing here, so you see the throttling policies. So we also have, so when you're looking at kind of the, kind of what's going on when you make one request versus another. So you're trying to optimize the property sets that you're using or the request patterns that you're using. You can look at these values here at the end, which kind of give you an idea of, this is total DC request count. So this is the total number of active directories, so like LDAP RPCs that were made by a given call. This is the latency of those requests. This is mailbox RPCs, so from the client access server to the mailbox server. How many RPCs do we make to the back end? This is the total latency of that request. So you can see some of these take much longer than others. We can look at why. And then we have the total request time. So this is the total time in milliseconds for a given request. And you can see this varies quite a bit. So this will show you, this is kind of just the variance that you could expect to see depending on the property sets you use and what properties you're requesting. You can have quite a bit of impact on the performance of your app. So one of the things that I typically do, so when I'm going through and I'm trying to optimize a particular app, so if I'm writing an app and we'll say it's this find inbox items app. Yep, you have a question?
Yeah, would you mind maybe zooming in on
Sure.
the spreadsheet a little bit? It's tough to read the actual
Yep.
data.
Yep. Is that better?
Much better.
Okay.
Thanks.
So one of the things I'll typically do, so obviously there's what, 31 lines in this log here. So this is obviously just my little test server running on my box that only my test apps are running against. If you have outlet clients, you're going to have many thousands of lines here. So you're going to have you're going to see a bunch of different user agents here. This obviously is a web browser hitting EWS. These are apps. This is a tool, EWS Editor. These tools use the managed API. So this is Exchange Services Client. That's the managed API. Shows you the version number of the managed API being used. So what if you're writing your app and trying to tune it or maybe trying to debug it in a production environment, you want to use a custom user agent that's easy for you to find and sort on so that you can go and get to this information quickly. And if you load this up into Excel, you can do some interesting stuff by loading it into, say, like a pivot table. And I'll zoom in on this. So you can load this into a pivot table, and you can pivot off like the user agent, or you could reduce it to a period of time that you're looking to troubleshoot. And you can look at, so I can look at my EWS Editor tool, what SOAP actions was it using, how many RPCs did they generate, what was the latency, where is my delay coming from? So I can look at the overall request time versus the mailbox latency. I can try to figure out my requests that are taking a long time, are they also taking a long time in the mailbox RPC compared to other requests? In some cases, that's true. So in one example here that we'll look at is this find inbox items 1, 2, and 3. This is a scenario where I'm maybe trying out, I'm looking to refactor my code, and I'm trying out 3 different ways of doing the same action. So I'm just using a user agent that's custom to each of them to try to see where I might get the best performance with which implementation. You can see here the RPC count's about the same. The latencies are quite a bit different, and the overall latency is quite a bit different. So we can look at the code for that. I'll zoom this in. So if I look at the first one here, this is using the managed API. So this will show you a little bit about how easy this is to use. So I pass in this Exchange Service Object. The Exchange Service Object is just the URL for EWS and the credentials, essentially. You can set other things like pre-authenticate or timeouts and things like that, very similar to an HTTP web request settings that you would have. So I'm simply just kind of obfuscating that from here, but I set the user agent on that. So this is where I'm setting find items 1. And then I set the what's called an item view in the managed API. That's that base property shape, the page view size. So the page size is 100. And I'm sending this request. I'm not setting anything, so it's just by default going to request all properties. So that's I call find items on the inbox with that view, and that's what's creating this result here. Find inbox items 1. So you can see that's a pretty big request in milliseconds, and I think there's about 50 items in my inbox. So it's getting all 50. It's requesting all props. So we go down to my next optimization, and so this is typically, what you're going to do. You're going to say, well, really, I need the item ID, I need the subject, the receive time, and maybe just the item class. So those are the only properties I really care about. So let me strip out, not use all properties. I'm going to use explicit property set. I'm still requesting all 50 items at one time. And if we go back, you can see the difference in response time here. So it's quite a bit of optimization that you can get. And then further down in the last example, so find inbox items 3 is simply, I'm simply just doing ID only. So that would be in a case where I wanted to just get every item in the inbox. Just let me collect all the IDs. That's the minimum amount of information you can collect for an item. So you can see it doesn't affect the RPC count necessarily. They're all just 3 RPCs apiece, but quite a bit difference in performance time. So it's kind of a final piece here. If you're familiar with Mappy and you've used that, there's another tool, and I'm not going to be able to zoom in on this to really show you. But this is EWS Editor. So this is, if you're familiar with MFC Mappy, so that's browsing a mailbox via Mappy. This is doing the same thing via EWS. So you can make different requests, perform different actions, so I can access the contacts. This is going to take a long time because this is Windows 8 running small business server in Hyper-V on my client here, so my laptop is struggling to keep up with me. So I can do different requests. I can navigate my way around through this, through the mailbox. And go back to the inbox so I can pull up some items. There's different actions built into this. So the export items, upload items, pulling MIME content, all these different things are kind of implemented in here. I talked a lot about best practices. EWS Editor is not a reference designed for best practices. It just kind of does what it does. If I get a chance to work on it some more, it might be a better representation of best practices. But you can kind of see it's the same value. It looks the same as MSC Map, if you're familiar with that. The nice thing about it is you can go and pull up this log viewer. And this log viewer in here shows you all of the EWS requests that it sent. So you can go through and you can look at each request that you sent, all the information that came back. So all the requests, the responses, the headers, all of that information. All of that is logged out. And that's using what Venkat and Daraji were talking about before, was the EWS Managed API has this ability to do tracing. So it's basically just a mechanism you set up, and you just turn tracing on, and for every request that you invoke through the API, it gets traced out, and you can write that out to a file and do whatever you want. So as you're, whether you're trying to understand EWS or create some representative SOAP to try to understand what the traffic looks like, what you could expect from items in different situations, kind of how the flow of requests go, you can use this managed API to write very simple code, turn the tracing on, and get the very complex SOAP requests and responses. So whether you're trying to understand what goes over the wire, or you're trying to understand how you implement a client or something like that, using the managed API with tracing is often a very relevant, useful tool. And then combining that with kind of visually being able to walk through a mailbox and do different things with EWS Editor and getting that information can be useful too. So any questions at this point? All right, that's all I've got for reading and writing. Thanks.